This is my second video lesson for Unit 13. In this lesson, we'll be identifying acids and bases. Go to page 8 in the class packet. Take a moment to read the motivation and answer the questions. Let's look at the first one. What is the name of HC2H3O2 aqueous? This is an acid. If you look on table K, it is acetic acid. Take a moment to watch a video on identifying acids and bases. The link to the video will be in the descriptions. Once you watch the video, resume this one. So why is acetic acid an acid? Let's look at the chemical equation. Sometimes in textbooks, acetic acid is abbreviated as HAC, but you should always read out the chemical formula of acetic acid. By looking at the equation, acetic acid is losing a hydrogen ion to water, which gains the hydrogen ion. This produces hydronium in the process. So water is acting as a base in this situation. So acetic acid is an acid because it produces H plus ions or hydronium in water. This is Arrhenius theory, and it also donates or loses H plus ions, which is Bronston-Lowry theory. So why is ammonium a base? Ammonium is NH3. In this equation, it takes a hydrogen ion from water, which produces NH4 plus ion and hydroxide ion. In this situation, water is behaving like an acid because it lost the H plus ion. So in summary, ammonium is a base because it produces hydroxide ions in water, and it takes and accepts hydrogen ions. So is water an acid or base? From the two examples, water can behave both as an acid and a base. Learning target. At the end of the lesson, I'll be able to identify if a substance is an acid or a base or both. Homework number 2 will be a Junipod based off this lesson. So water can behave both as an acid and a base. This is known as amphoteric, which means it can react as both an acid and as a base. Amphoprotic means it can both accept and donate H plus ions. So amphi means both. So water can be amphoteric and amphiprotic. There are substances that are amphoteric but not amphiprotic because there's no hydrogen. Learning check number 1. According to acid and base theories, the water can act as a what? Pause the video and resume as completed. The answer is choice 3, either an acid or a base. Learning check number 2. Which species is amphoteric? Pause the video and resume as completed. So you're looking for a situation in which it can gain and lose a hydrogen ion. The only one that can do that is choice 2. Choice 1 and 4 are considered acids and they cannot gain a hydrogen ion. Associate means to join or connect. Dissociate means to disconnect or separate. Building on prior knowledge, why do ionic compounds dissociate in water? So here's a diagram showing NaCl, which is an ionic compound, dissociating or breaking apart in water. This is because ionic compounds are very polar. If we are given an acid and a base, do you expect them to dissociate as well in water? The answer is yes, because they're also considered very polar molecules. Which theory suggests this? Arrhenius theory. So acids form hydrogen ions in aqueous solutions, while bases form hydroxide ions in aqueous solutions. So both acids and base dissociate in water, forming the respective ions. On the Regents exam, you must be able to draw a particle diagram of what happens when a salt, acid, or base dissolve in water. So let's look at some examples of correct answers. Here's a dissociation of salt. We're going to draw water molecules around each ion. Since water is a polar molecule, the oxygen is partially negative and the hydrogen is partially positive. So you want the oxygen to face the positive ion and the hydrogen to face the negative ion. Do you expect acids and bases to be electrolytes? How do you know? Electrolytes are substances that conduct electricity when dissolved in water. By looking at these diagrams, the acids and bases, when dissolved in water, dissociate into ions. These ions can move around. So acids and bases can conduct electricity because mobile ions are formed in solution. Learning check number 3. Which substance is an electrolyte? Pause the video and resume as completed. The answer is choice 4, because H2SO4 is an acid according to Table K. Learning check number 4. Which substance yields hydroxide ion as the only negative ion in aqueous solution? Pause the video and review completed. The answer is choice 1, because magnesium hydroxide is a base, so when it dissolves in water, it will dissociate into a hydroxide ion. Choice 3 will not dissociate into hydroxide ion because this is a covalent compound. Learning check number 5. Which compound dissolves in water to form an aqueous solution that can conduct an electrical current? Pause the video and resume once completed. The question is asking about an electrolyte. The answer is choice 2 because it is an acid, according to Table K. So in summary, acids and bases have high polarity and they are electrolyte. In the next part of the lesson, we're going to identify Lewis acids and bases. Keep in mind, this is not on the regions. Lewis acids tend to gain electrons, while Lewis bases tend to lose electrons. Here are some possible characteristics of Lewis acids and Lewis bases that you can use to identify them. Lewis acids tend to have a positive charge or a partial positive charge. They have an atom in a molecule that has less than 8 electrons in the valence shell when bonding, for example, boron, one end of a polar double bond, or the molecule has an atom with expandable valence shell, like phosphorus or sulfur. For a Lewis base, here are some possible characteristics: has a negative charge or a possible negative charge, have lone pairs, the other end of a polar double bond, or a presence of a double bond. Let's look at a couple examples. Here we have a fluoride ion reacting with Bf3 to give us Bf4-. The fluoride ion has a negative charge and it donates 2 electrons to form a bond with this boron. Therefore, fluoride is a Lewis base. The boron in Bf3 has 6 electrons and has an empty orbital. Therefore, it will accept electrons from the fluoride ion. So this is considered a Lewis acid. Let's look at another example. Here we have oxide ion with a negative charge and it donates 2 electrons to the sulfur in this chemical reaction. So oxide must be a Lewis base. Since the sulfur in the molecule is accepting electron, the molecule is a Lewis acid. Let's look at one more example. The aluminum ion has a positive charge and in the reaction it accepts electrons from the oxygen. Therefore, it is a Lewis acid. The water molecule is behaving like a Lewis base because the oxygen is donating electrons to the aluminum ion. Here's another way to identify Lewis acids and bases in oxides. Oxides are binary compounds of oxygen with another element. Treat these as guidelines because there will be exceptions. Basic oxides are oxides of metals that are basic. If a metal is bonding with oxygen, then the compound is considered a Lewis base. Metal oxide hydrolysis, which is when a metal oxide reacts with water, this forms hydroxides, which is considered a base as well. Amphoteric oxides are oxides of a metalloid or elements near the staircase in the periodic table. Acidic oxides are oxides of nonmetals. Here are the periodic trends. Acidity increases from left to right. Basicity increases from right to left. Acidity increases from bottom to top. And basicity increases from top to bottom. Treat these trends as guidelines because there will be exceptions. Let's look at some examples. CO2 is considered an acid because carbon is a nonmetal. K2O is a base because K is a metal. Calcium hydroxide is a base because calcium is a metal. The next one is amphoteric. SO3 is considered acid because sulfur is a nonmetal. N2O5 is also considered acid because nitrogen is a nonmetal. SRO is a base because SR is a metal. Learning check number 5. Which of the following can be a Lewis acid? Pause the video and resume once completed. The answer is choice 2. Choice 1 is a base. Choice 3 is a metal oxide, which is a base as well. NaCl is a neutral ionic compound. Learning check number 6. Which of the following can be a Lewis base? Pause the video and resume as completed. The answer is choice 4 because it's a metal oxide. In practice number 1, identify the acid and base in the reaction. Try to do it yourself. Pause the video and resume as completed. Here are the answers. The red box is an acid. The blue box is a base. For practice number 2, identify the following as an acid or base. I would do questions A to I, and then you could do the rest yourself. Question A, HF is considered an acid because H is in front in the chemical formula. NH3 is ammonium, which is base, is also on table L in your reference table. Question C is acetic acid. It is found on table K on your reference table. Question D is also an acid because H is in front in the chemical formula. Question E is an ionic compound with hydroxide. This is a base. Question F is a basic oxide, which is a base. Question G is an acid because H is in front in the chemical formula. For question H is also an acid because this is a nonmetal oxide. For question I, is ethanol an acid or base? Let's analyze which one is correct. Ethanol is a covalent compound. When it dissolves in water, there are two possibilities. Either the O and the H bond dissociate, or the C and O bond dissociate. If the first scenario happens, then ethanol is an acid. If the second scenario happens, then ethanol is a base. It turns out the first scenario is correct, and the second scenario does not happen. So why is that? The OH bond is stronger than the CO bond. So why is the stronger bond broken and the weaker bond not? Because of intramolecular forces. When ethanol dissolves in water, it forms hydrogen bonding. Water hydrogen bonds to the O- and the H+. Water cannot hydrogen bond to the C+ in the second scenario. Covalent compounds with OH groups are called alcohols. We will discuss this in Unit 15, Organic Chemistry. Since alcohols have a similar structure to water, they can act as an acid or base depending on the situation, but they usually behave as acids. On the reagents, they are considered neutral non-electrolytes. Learning check number 7. Which pair of compounds represent one Arrhenius acid and one Arrhenius base? Pause the video and resume is completed. The answer is choice 3. That's the best answer. C3OH is an alcohol and is considered neutral. Try to do the rest of the questions yourself. Pause the video and resume is completed. Here are the answers. This concludes the video lesson. Remember to do the JunoPod homework.